Hi, I'm Smitha Sheshadri. Identifying the user's starting or initial position is the necessary first step in offering any location-based service. However, indoor human localization still remains a challenge, mainly due to the lack of access to accurate GPS. Existing sensor-based approaches, although accurate, face problems in practice like the high cost of deployment, incompatibility with existing devices, and latency. In our work, we propose indoor human localization through intelligent conversation. We ask the question, can we design an autonomous agent that can identify a user's indoor position by having a conversation with them? Specifically, we investigate 1. Is it possible to localize people based on conversation? And 2. If it is possible, what are the technologies we need to automate conversational localization? To answer the first question, we conducted a visit-a-pause study. A member of our research team assumed the role of the hypothetical agent and engaged the participants in conversation via text messaging on Discord. The result was we found that the experimenter was successfully able to locate the participants based on talking to them. Therefore, we conclude that it is possible to carry out localization based on conversation. We found that in assuming the role of the hypothetical agent, the experimenter was extracting entities from the raw unstructured descriptions, selecting the best suited entities for localization, and then using them to infer the participant's geographical location based on the prior knowledge of the study site. We conducted technical investigation into these steps and developed tools to aid the processing of raw user descriptions. We developed a custom named entity recognizer by devising grammar rules for sequence extraction. To select the best suited entities for localization, we compiled 4 dimensions to categorize this inherent usefulness of entities. To assess the effectiveness of our tools, we conducted a study on Amazon Mechanical Turks where we recruited 80 participants and collected 800 descriptions. We collected virtual tours from different locations from our university campus for the participants to describe. Our NER was able to identify 99.11% of the manually identified entities, and our entity suitability scale allowed us to concretely rank them based on their suitability for localization. With our tools, we can process raw and unstructured user descriptions and extract the most relevant parts from them. We can also rank the extracted entities based on their suitability for indoor localization. For our future work, we are focusing on obtaining geospatial boundaries of the extracted entities based on available floor maps.